Hey, this is Mr. Aiden, this is Physics Honors, and we're going to be talking about the duality of nature. Whether we are good or whether we are bad. Wait, no, that's duality of nature that Mr. Dale teaches in his literature classes. We're talking about the duality of nature in physics. And so what we've been studying is the wave nature of light, haven't we? We've studied the electromagnetic waves, radio waves, and microwaves, and visible light, and ultraviolet rays, and gamma rays, and that these electromagnetic waves they propagate as photons. And there's many experiments to show that our light, our electromagnetic light or waves, travel in photons or in waves. And if you want to watch a really cool video, watch the original double slit experiment by Veritasium. It is one of the coolest videos to show an experiment that's done to show that light travels as waves. And you might say, Mr. Aiden, I knew that light travels as waves. They travel as photons. Waves, I know this. We've studied the Doppler effect. We've studied diffraction. We've studied refraction. We've studied reflection. We've studied all these things. Well, I want to give you one experiment, this double slit experiment. The amazing thing about the double slit experiment was done by a guy named Young. And Young's double slit experiment, he shot a wave of light, and what he saw was there was constructive interference and there was destructive interference, which meant when he looked at a screen, he saw not just two things of light from this double slit, he saw different fringes of light. Let me show you what that looks like. This is what Young's double slit experiment looks like. He shot a beam of electrons, even though electrons are particles, but they exhibited wave-like properties. They had constructive and destructive interference. What he saw on a screen was fringes. And you can actually do this at home. If you get a piece of paper, you make two tiny little slits very, very, very close together. You shoot it with a laser. You go into a dark, dark, dark room. You'll see Young's double slit experiment. But the amazing thing is this, is when they did it with electrons, particles, he saw it go through and provide the same thinking. It had constructive and destructive interference. And the cool thing is this, you can have even different things of diffraction. You can put a tiny, 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 tiny square, and you won't just see a square of light, you'll see a bunch of different fringes. And whether that square has different dimensions will change what type of fringes you get. If you do a little circle, you won't just see a circle, you will see different fringes. And if you change this to different sizes, you will see different fringes as well. And so all kinds of you can get different patterns when you have different slits, which means light moves as waves. But the cool thing is we found there was another experiment at the turn of the century called the Photoelectric Effect, done by a guy with some goofy hair named Albert Einstein. And what Albert Einstein did was this. He took a piece of metal, okay, like a piece of potassium metal, and he shone different lights upon it. So first he showed a wavelength of red coming in here. And guess what? The metal absorbed all of the red light. But when he took something with a little bit of a higher energy, like say green light, okay, and as he took this green light, came in here, well, it absorbed some of that green light, but off came one particle or electrons. So in came a wave and out came a particle. And what do you know? When he shined something like purple light on, something with even higher energy, a higher frequency, it absorbed this purple, but guess what? Off came a bunch of electrons. And I like to think of it like, it's kind of like a cup, okay? And we have a cup here, and guess what? When we put in red light, well, the red light just fills the cup up this much with energy. So the metal can take just a tiny bit of energy. But when we did something like green light, well, green light put in more energy. And when we put purple light put in way more energy, and there was an overflow. And that overflow was electrons. But what Albert Einstein found was that electromagnetic radiation wasn't just waves, but it exhibited particle-like behavior as well. And the cool thing is, we call that, actually, let me show you a simulation of this. Here I have some photons of some infrared light, and now let's go to red light. You can see the red light is still being absorbed by all the potassium. Let's come down to yellow light, it's still being absorbed. Let's come down to green light, still being absorbed. Let's come down to like this tealish color, blue. Okay, blue. You can see what came off was some electrons. Now, it didn't make it all the way, did it? But we got some electrons coming off. But watch purple light. The electron makes it all the way to the other side, and we were able to detect the electrons, which means that this wave of light also had particle-like property. And when we have something like ultraviolet light, which has tons of energy, you can see there's going to be way more electrons that come off. And so the cool thing is this is called the duality of nature. The duality of nature says that electromagnetic waves exhibit characteristics and properties of waves, which we call photons, and particles, which we call electrons. So photons and electrons, waves and particles, and that is called the duality of nature. Have a great day, guys. Don't forget your self-assessment.